Okay, another way that we've learned to do division is by using the Big 7. The Big 7 is similar to the algorithm that I learned when I was in school. So reading this problem here, it tells me there are 1,248 students who signed up for the Super Saturday celebration at the high school. The teachers want to split the students equally into the mighty mathematicians, the super scientists, and the radical readers. How many students are in each group? Well, I need to write down what I know. I know that I have 1,248 students. I know that those students are going into the mighty mathematicians. They're going into the super scientists, and they're going into the radical readers. They're going into 3 groups. Okay. In my next box, I want to make sure that I know what operation or what action I'm going to take. So I'm going to draw myself a strip diagram just to make sure that I fully understand. So my strip diagram always starts out as a pretty basic rectangle. I've been given my total amount, which is my 1,248 students. I know that those students are being split into 3 groups. So I'm going to divide into 3 groups. We have our mighty mathematicians, our super scientists, and our radical readers. But I don't know how many students are going into each group, so I need to figure that out. That's where my question mark is going to go. So looking at this problem, I know because I've been given a total in my groups that I need to divide. So we're going to take this we're going to do this division problem with a different strategy than the last one. We're going to use the Big 7. So my 1,248 is going to go inside of a Big 7. My 3 groups are going out here. Now, just like our area model, what we did is we had to think of the biggest groups that we could put in there, but we wanted to start with our friendly numbers, our numbers that we were comfortable with. Well, I'm comfortable with hundreds, tens, fives, twos. Those are the numbers that I know the best. Those are the numbers that I want to try and use first. So I think about it. Well, if I put in 100 into 3 groups, that's 300. I think I can do better than that. What if I put 200 into each group? That would give me 600. That's looking better. But I think I could do more. What if I put 300 into each of my 3 groups? Well, then I would have used 900 things. But I have 1,248. Let me see if I can do another one. What if I put 400 things into 3 groups? Group 1 had 400, Group 2 had 400, Group 3 had 400. Well, when I do that, I've used 1,200 of my students that I was trying to divide out. I can't use them again, so I need to subtract them and find out how many more students I have to divide. So now I have 48 students left to divide into my 3 groups. Okay, again, let's go back to our comfortable numbers, hundreds, tens. I'm really comfortable with just a group of 10, so let me put that group in there. So if I put 10 students into each of my 3 groups, that's 30 more students that I've divided out. Now I'm left with 18 students. Okay. Well, thinking, what times 3 is going to give me 18? Well, I know that 5 times 3 is 15, so 6 times 3 would be 18. If I put in a group of 6, each into my 3 groups here, I've used 18 more things. I'm left with 0 students to divide out. But what I have to do is I still have to add my partial quotients. These are pieces of my answer that I need. So 400 plus 10 plus 6 gives me 416 students. I can easily check myself by taking my quotient and multiplying it times my 3. So if I do 416 times 3, I should get my 1,248. I'm going to go back to my multiplication strategy, break my 416 apart by place value, and multiply it times my 3. 3 comes over, meets my 6. 3 times 6 is 18. My 3 comes over, meets my 10. 3 times 10 is 30. My 3 comes over, meets my 400. That's 1,200. I need to add my partial products together. 1,200 plus 30 plus 18. And when I add those, I come up with 1,248, which was my original number that I was looking for. My division checked out. 416 students would be in each of my 3 groups.